we're starting creating the planet at y sub 1. This is the upper tip of the planet, and we are ending with the first half of the planet at y sub 2. Y sub 2 is the equator of the planet. Now, what is y sub 1? Y1, it is h slash slash 2. It is just the same as, remember that our h is 300. In Python programming, if it is slash slash 2, we need um, we need to have an answer that is an integer. 300 divided by 2 is anyway an integer, so there is no problem with that. Now, what is h slash slash 4? That's going to be a 300 divided by 4. Well, anyway, again, there's no problem with this because the answer is an integer. I put here the formula for number 12 so that you can apply this in any screen size that you have. You might have a different dimension that I have now. My dimensions anyway are for the h, it is 300. I'm writing on number 5. And then for my width, it is 400. Incidentally, y1 and y2 are over here on the right side of the screen. This is y1, the upper tip of the planet, and this is y2, the equator of the planet. And you can, yes, actually y1 and y2, they are values on the y-axis of the rectangular coordinate system. Now let's go to the creation of the upper half of the planet. I defined here the upper half, command number 17. Um, Number 18, this is very important in creating gradients. A gradient is actually a plane that illustrates um, the smooth change from one color to another color. Remember, in our planet here, um, we are transitioning from white, the polar cap, to blue near the equator. And then, yes, when we go to the second half of the planet, this is still blue. And then the blue is slowly giving way to the white, the lower polar cap. Number 38, we have two variables here, the count. Of course, the count changes from um, 0, 1, 2, 3, 4, 5. And then the second variable is y. The y changes from y1, which is defined in number 12, and ends with y2, which is defined in number 13. And change in the value of y is -1. So the value of y actually decreases as we go from the upper tip of the planet to the equator of the planet. That's for the first half of the planet. Now we define the length here because I need to define here the starting point for the drawing of the lines. The equation here is quite complicated, but I hope that you still remember the formula for the circle. The formula here is derived from, okay, let me put here. This is derived. This is derived from x squared plus y squared is equal to r squared, where the r is the radius of the circle. The way it is presented here in number 19, this is the value of x, the positive value of x. I'm only considering here the positive value. So this is the square root of the r squared. In our case, the r incidentally is h slash slash 4. And yes, the y is in the equation of the circle formula. Once we have defined the length here, I put the pen up because at this point my turtle is at 0, 0. I'm checking on that on the right side of the screen. And then I define my x here, the x value in the rectangular coordinate system. It is equal to the negative length. And then I also define my y here so that I know where to put the turtle to start drawing. The y here is whatever y I have in the loop here. The first y that I have, remember, is y sub 1 here. So the y here is y sub 1. And what is y sub 1? It is 150 minus 75. So that's 75. So I go now to xy. Note that I don't generate any line here because my pen is up. And then I put my pen down to draw the first line. Incidentally, the first line is just a point. Why? Because when you go back to the formula here in number 19, the difference between h slash slash 4 and y is 0 because y is equal to h slash slash 4 anyway. Look at this. What is h slash slash 2? I'm focusing on number 12 minus h slash slash 4. That is equal to h slash slash 4. So since the h slash slash 4 here in number 19 is equal to y, so the first value of the x here is 0. So when I draw number 25, it's just a point. And this is the upper tip of the planet. Now, after drawing the supposedly first line there, which incidentally is, which actually is a point, I change the color now.